In this video, we are going to discuss hyperbola, which is our fourth and final conic section. Really, you could think about it as three because a circle is just a very special ellipse, but we have talked about parabolas, circles, and ellipses, and now we're going to discuss hyperbolas. So hyperbolas have this extreme opposite direction. They're basically curving away from each other. And hyperbolas have what we call a transverse axis. So there's a center, and the center isn't a point on the graph. It's a little invisible anchoring point. But the center here, in this situation, and all the problems we're going to be doing in this video, will be at the origin. So we've got centered at the origin, and along that transverse axis, we have two vertices. And then you can see we've got two foci. So in this case, we have a horizontal transverse axis. The hyperbola pieces are opening to the left and the right. And by definition, a hyperbola is the set of all points in a plane for which the absolute value of the difference, so this distance and this distance, if I subtract those two distances, the difference of those distances, the absolute value, would always be constant. So from foci to any point on the hyperbola down to the other foci, subtracting d sub 1 from d sub 2, regardless of how that is created, like this. Subtracting those two and getting that difference, the absolute value would always be the same. That represents a hyperbola. All right, so we've got a center, we have two vertices, and then two foci. So let's get into our standard form for hyperbola, which are centered at the origin. As I've mentioned, dealing with hyperbola, they're very similar in the way they look to ellipses. So for example, we have x squared over a squared minus y squared over b squared equals 1. And a vertical transverse axis hyperbola would look like y squared over a squared minus x squared over b squared equals 1. So what is different about this and an ellipse? Remember, an ellipse had a plus sign between those two terms. And when you're adding two terms, it doesn't matter the order, we should say, for the terms, because addition is commutative. Subtraction is not commutative. So the way we will identify a hyperbola is which comes first. So for horizontal, we have x minus y, and then for vertical, we have y minus x. That's how we discern. Now with an ellipse, the a and the b were larger values. In this case, they can be either size. A or b can be the bigger number. What we're going to be focused on is the value that comes first and the value that comes second. So again, the order of A and B matters. So I have x squared minus y squared. X squared minus y indicates horizontal. Y squared minus x squared indicates vertical. The A value is whatever comes first, which represents our major transverse axis, horizontal, or in this case, vertical. So A is under the Y. And then B comes second. So the difference here between an ellipse, because I know this looks similar, is that an ellipse, the A value was bigger and the B value was smaller, period, the end. But with a hyperbola, the magnitude of each of these A and B values doesn't matter. They can even be the same, okay? What matters is their placement. So A is going to come first. A is under X for a horizontal. A is under Y for a vertical. So again, reiterating that A value can be less than or even equal to B in a hyperbola. Now, the difference with an ellipse is we need to know which axis was longer. That longer value gave us our major axis. But in this situation, the axis can be, shorter or even equal. A and B had to be different with ellipses because if A and B were the same, then we ended up with a circle. All right, let's list our attributes, which are going to be center, vertices, and foci, and we're also going to have asymptotes here. Now, in both of these situations, the center is at the origin. So my center is going to be 0, 0. The vertices are still identified using your A value. So remember, A is what comes first, B comes second. So my vertices for a horizontal ellipse, that means the change is going to be in X. And I will have A comma 0 as well as negative A comma 0. My foci, which come from the C value, the foci would be C comma 0 and negative C comma 0. And we'll talk about our C formula in a second. So notice this was horizontal. A and C made changes to my X coordinate from the center. It's going to be the same patterning for vertical, but the change is going to occur in Y. So I'll have 0 comma A, 0 comma negative A, and 0 comma C, 0 comma negative C. And the foci formula, very similar to what we used before, C squared equals A squared, this is important, plus B squared. So C squared equals A squared plus B squared. So for an ellipse, the standard form had pluses and the C equation had a minus. But for a hyperbola, it's the opposite. My C equation is going to have the plus and that standard form has the minuses. All right, so we also have asymptotes. And we want to think about the asymptotes as being y equals mx plus b, right? So it's the equation of a line. In this situation, my lines, my asymptotes, since we are centered at the origin, will be passing through the origin, and that b value is 0. So I'll have two asymptotes formed by y equals mx. So one's going to have a positive slope, and one will have a negative slope. So I'm going to say plus or minus whatever that m value is, x. Now the slope is found for a horizontal asymptote. We're going to say b over a. Now think about what you know about slope. When you say slope, we say rise over run, or change in y over change in x. Notice the b value is under y and the a value is under x. So we'll say b over a. So we'll get two lines. We'll have y equals b over ax and y equals negative b over a x. Now for a vertically oriented transverse axis on the hyperbola, it's going to be the same. We'll have y equals plus or minus some slope times x. Now if we go up and look at our vertical here, what value is under y? A is under y, b is under x. So this ratio is going to be a over b. Again, thinking about slope. So a over b. And all that plus minus does is create two equations. All right, so let's look at what these graphs would look like. First thing I'm going to do here is graph my horizontal transverse axis hyperbola. So thinking about what we know, now these are centered at the origin. So if we have a horizontal transverse axis, that means the axis passing through both my hyperbolas is horizontal. So my center, again, not a point on the graph, is 0, 0. My vertices are going to be A units out to the left and right. And my foci, again, since my foci have a plus in them, that number is actually going to end up being bigger and they'll be further out to the left and right on either side. Okay, so the hyperbola will pass through the vertices and again hug or wrap around the foci. They focus their attention about the foci. The easiest way for us to draw these is to draw the asymptotes. So the asymptotes, and this is a really helpful way to think about it, we have a horizontal distance out, which is A. We have a vertical distance up, which is going to be my B. So I'll have a positive B and a negative B. And what that allows me to do is I'm going to draw a box, a rectangle through my A and B values. So again, those are my vertices, and then the B values, those are also not points on the graph. The only points that we've plotted are our two foci, which are C0 and negative C0, as well as those two vertices, which are A0 and negative A0. So what we get from this is if we think about the slope, rise over run, B over A. Rise B, run A. B over A, that takes me right through these diagonals. So we get these nice, drawing this box gives us this nice way to develop our diagonals. And my hyperbola now is this curve which passes through each vertex and wraps around the focus. So there's a lot of stuff I've drawn here that isn't necessarily on that graph, but I want you guys to understand what I'm doing in order to draw this, especially because you may have to draw this on your testing class or on a lab. All right, so looking at a vertical transverse axis is going to occur the same way. Here's my vertical transverse axis. My center is at 0, 0. I'm going to shift up A units for each of my two vertices. So those ordered pairs would be 0, positive A and 0, negative A. And then my foci are a little bit further out. Those might be 0, positive C and 0, negative C. So at this point, I use my B values to shift horizontally off the center, and B could be further out. B can be larger than A. What those B values let me do is to draw a rectangle. And I use this rectangle, which passes through my vertices, to help me figure out how to draw those asymptotes. So my asymptote is going to be passing right through those corners. You can see we're going to end up with a really wide parabola here. I'm sorry, hyperbola. These are hyperbolas. So it's symmetric. Mine isn't going to be perfect because I'm doing this by hand on an iPad, not paper. It'd look much nicer if I was drawing it on paper. I digress. Here is my vertical transverse axis. Transverse passes through each hyperbola. All right, so let's do an example. Now that we've really defined this, let's talk about, we've got two little examples with hyperbola centered at the origin. For the first example, we're going to write the equation of a hyperbola given some of its attributes. We know that the hyperbola has two vertices as well as two foci. So one thing that might help us would be to plot those. And if we look at what's happening, my vertices are going to be 4 units up and 4 units down. So I've got 0, +4 and 0, -4. And my foci are going to be 6 units up and 6 units down. So what is the orientation for this hyperbola? Notice all of these lines, or all of these dots, are on a vertical axis. So it's a vertical transverse axis hyperbola, which means the equation is y² over a² minus x² over b² equals 1. So y² comes first because this is a vertical hyperbola. Now, the a value comes from your vertices. So we know that a equals 4. What we do not know is the b value. The c value for foci, we know that c is going to equal -6. And c² equals a² plus b². So this is similar but different to an ellipse. c² equals a² plus b². So I'm going to use this equation to find b. And I wrote up here, I'm noticing I wrote c equals -6. C is just +6. We say plus or minus 6. So anyways, we have 6² or 36 equals a², 4², which is 16, plus b². So that means that 36 take away 16, 20 equals b², or rather b equals plus or minus the square root of 20. We're only going to use the positive value because it doesn't matter if it was positive or negative. When we plug it in, it's going to be squared. We can simplify that, and that will be 2√5. So b is 2√5. And that means the standard form is y² over a², which is 16, minus x² over the square root of 20², which is just 20, equals 1. Now I have the equation for my hyperbola. It's a vertically oriented hyperbola in standard form. All right, one more example. Here, we're going to identify the conic, state its orientation, and then any pertinent attributes. All right, now again, you know this is a hyperbola because we're in the hyperbola video. But on the test, no one's going to be there to tell you. So how do we discern? One thing that we notice is we have both x² and y². Automatically, we know it is not a parabola. We also notice that the coefficients are different. Different coefficients means it is not a circle. Okay, so we got a 9 and a 6. Hyperbolas and circles can have the same number. And then we notice we have different signs. So ellipses and circles would either both be plus plus or minus minus. Different signs means it's not an ellipse. So if it's not those other three things, it must be a hyperbola. It's a hyperbola, and we can't determine the orientation until it's in standard form equal to +1. Now, you may be looking at this and saying, well, Ms. Stein, this is x² minus y². It must be horizontal. Well, what if this value was negative? If I had a negative value over here on the right side and I divided by it to get -1, that would change these signs. So really, you need it to be equal to +1 in order for you to determine the orientation. So I'm going to divide all of these terms by 144, and because this is a positive number I'm dividing by, I know my sign values won't change. But again, if it was somehow negative, that could change these two signs, and then it could be a vertical. So 9 over 144 is 1/16. So I have x squared over 16, and 16 over 144 is 1/9. So I've got y squared over 9 equals 1. I like to go one step further when I'm putting it into standard form. And you remember we said a squared and b squared. So I just like to write those as their roots squared. So 4 squared minus y squared over 3 squared equals 1. Now it's in standard form. Because it is x squared minus y squared, we know this is going to be a horizontal transverse axis hyperbola. Now, the a value is first. A is first. So a is 4. And my b value is second. B is 3. Now there's no shift on x or y, so this is centered at the origin. And again, we'll talk about translated, shifted hyperbolas in the next video. But we can find our c value. Remember, c squared is a squared plus b squared, or c squared equals 16 plus 9. C squared equals 25. We get that c is going to be 5. So let's look at listing our attributes and graphing this. As we've just said, this is a horizontal transverse axis hyperbola, which means we're going to have some horizontal axis, in this case through the origin, where all of our points are going to be located. So here, again, it's centered at 0, 0. We don't have a shift. So I'm going to be moving all of my points, my vertices and my foci, horizontally out from the origin. The center, as we just said, is at 0, 0. Now that is not a point on the graph. The foci are 5 units out to the left and right. That's going to give us an ordered pair, positive 5, 0, or negative 5, 0. And of course, I know that those 5s go in the x coordinate because it's horizontal. My vertices are going to be 4, 0, or negative 4, 0. So let me plot those points. So I have my 2 vertices, each 4 units to the left and right of the origin, and my 2 foci, each 5 units to the left and right of the origin. So let's talk about our asymptotes and creating this little invisible box. Notice my b value is 3. That has to do with my minor axis. So I'm going to shift out 3 units on each of these axes, and that allows me to create a little box here that is 8 wide and 6 tall. So if we were drawing an ellipse, the ellipse would go inside this box. And the reason I draw this little invisible rectangle is because that helps me to draw my asymptotes. My asymptotes are going to be passing through. So my asymptotes in this situation, remember, we're going to write them as an equation here. We're going to write y equals plus or minus some m value times x. And since it's going through the origin, we don't have plus b, because plus b, the y-intercept, is 0, the origin. So we need to know what the slope is. Remember, slope is rise over run, or change in y over change in x. Which value's under y and which value's under x? 3 is under y, 4 is under x. So in this case, my 2 equations, they're going to be y equals positive 3/4 x, or we'll have y equals negative 3/4 x. So those are my 2 asymptotes. And you'll see if I go to sketch those right now, that slope If I went from the origin and I went rise 3, run 4, it takes me to that corner. Or rise -3, run -4, takes me to the, again, opposite corner. So I've got one asymptote right here, passing through the corners, and my other asymptote. That is not very straight. So these are my two asymptotes, and my hyperbola passes through each vertice, wraps around the focus, and hugs up, is asymptotic to these asymptotes. So this is my graph of the hyperbola. All of this gray stuff in the middle, that's not really there. This is my hyperbola. I just used the asymptotes to help me draw the curve. Of course, these should be a little bit more symmetric, but I think I ran out of space. And I'm also drawing by hand. I paused, I made my picture look a little nicer. Again, that rectangle is not really there. We just used it to help us draw. So we've got our two vertices. The hyperbolas pass through the vertices. They're opening horizontally. They open to the left and right. So everything would be the same, just tweaked a little bit for a vertical hyperbola. As always, email me if you have any comments, questions, concerns, because I am here to help. Good luck.